Maicanina Rodriguez, and I will report about IT standards, imaging, and Internet standards. The switch of an analog to a digital working environment put a radiologist at the front line of the producing and distributing digital images. New dedicated software products were developed such as PACS, RIS, and HIS. This also led to the development of standards for electronic transmission of radiological images such as DECOM standards. The digitization of the radiology and the fast-growing availability of high-bandwidth internet were the main contributors to the onset of teleurology and the transmission and reading of the radiological images at distance, such as often from outside the hospital. In many radiology departments, teleurology services became part of the daily workflow, mainly to solve such as problems as increasing workloads, shortage in radiological capacity, and demand for subspecialty advice. So, to summarize, the radiologist in his role as a manager could make an optimal use of information technologies or IT in four principal fields, namely the management of workflow, the interpretation of images, the treatment of patients, and the communication with clinicians and patients. So being confronted with an increasingly workload, IT can be used to monitor the work processes, to optimize the workflow, and simplify procedures. The integration of automated information findings and quantitative omics data where relevant information could optimize the information provided in radiology report. In this data-rich environment in which the context is king, radiology should embrace artificial intelligence to simplify the process of enriching their reports with this data. Use of IT should enable radiologists to assist in selecting more personalized or less invasive treatment options for patients. Finally, IT could support the communication of radiologists with clinicians and patients and facilitate a more direct communication between radiologists and patients, enabling patients to contract the radiologist for an examination of the findings could create a greater awareness of crucial role of radiologists. With portals providing access to radiology reports, this will become a requirement. Crucial in such management model in the optimal interoperability between health data system and the 24/7 availability of all relevant patient data. The patient should be full owner of the data and therefore should have the possibility to decide who is authorized to make use of them. So at the picture, a software application to make structured multimedia reports consisting of graphics, presentations of patients, shows interactive key images of each anatomic region. By clicking on this image, all relevant information of the related body parts became visible. So next is DECOM standards. Digital imaging and communication medicine is an international standard to transmit, store, retrieve, print, process, and display medical imaging information. DICOM makes medical imaging information interoperable. It integrates image acquisition device, PACS, workstation, VNAs, and printers from different manufacturers. It is actively developed and maintained to meet the evolving technologies and needs of medical imaging, and it is also free to download and use. The DECOM Standards Committee is an independent international standard development organization comprising biomedical professional societies whose specialties include the use of medical imaging manufacturers of medical imaging equipment and related information systems, and government agency, trade association, and other standards development organization with an interest in standardization of medical imaging information and related data. Digital imaging communication in medicine is a standard for communication and management. A medical imaging information and related data. The DECOM standard facilitates interoperability of medical imaging equipment by specifying for network communication a set of protocols to be followed by devices claiming conformance to the standard. The syntax and systematic of commands and associated information that can be exchanged using these protocols. A set of media storage services to be followed by devices claiming conformance to the standard file format and a medical directory structure to facilitate access to the images and related information stored on interchange media. The global applicability and localization is a worldwide standard that can be used in every local. It provides mechanism to handle data that supports cultural requirements such as different writing system, character set, language, and structure for addresses and personal names. It supports the variety of workflow processes and policies used in biomedical imaging in different or geographic regions, medical specialties, and local practices localization to meet the requirements of national or local health and workflow policies can be done without deviating from work standards. Such localization may include specifying code sets or profiling data elements usage. Localization and profiling can be specified in a number of mechanisms outside the purview of the DECOM standard. One such mechanism in integration profiles from the integration that the Healthcare Enterprise or AHE organization. It is an important that profiling adhere to the concept of non-contradiction and profile can add requirements but should not contradict, contradict, contradict DECOM requirements, as the as that would make it impossible to comply with both DECOM and profile. So, how does DECOM work? There are two main components of DECOM. There are DECOM file format and the DECOM network protocol. These two elements work together so that images are in standard format and exchange of images is also standardized. Finally, DECOM works between everybody's use. If if a device is not DECOM compliant, no one is going to buy it in today's healthcare world. Next is HL7 standards. HL7 HL7 refers or a health level 7 refers to a set of international standards for transfer of clinical and administrative data between software applications used by various healthcare providers. These standards focus on the application layer, which is the layer 7 in the OIS model. The HL7 standards are produced by Health Level 7 International, an international standards organization, and are developed by other standard issuing bodies such as American National Standard Institute and International Organization for Standardization. HL7 International specifies a number of flexible standards, guidelines, and methodologies by which various healthcare systems can communicate with each other. Such guidelines or data standards are a set of rules that allow information to be shared and produced in a uniform and consistent manner. So there are two versions of messaging, messaging standard. Version 2 messaging standard and interoperability specification for health and medical transaction. Version 3 messaging standards and interoperability specification for health and medical transaction. Next is clinical document architecture, CDA, an exchange model for clinical document based on HL7 version 3. Continuity of care documents or CCD, a use of specification for the exchange of medical summaries based on CDA. Next is structured production labeling, SPL, the published information that accompanies a medicine based on HL7 version 3. Clinical Content Object Workgroup or CCOW are interoperability specification for visual integration of users' application. Fast Healthcare Interoperability Resources or FHIR, a standard for exchange of resources, and Arden syntax, a grammar for representing medical conditions and recommendations as medical logical module or MLM. Claim attachment, a standard health attachment to argument, another healthcare transaction. Function specification of electronic health record or personalized health record or PHR systems, a standardized description of health and medical functions solved for available in such software application. Jello, a standard of expression language used for clinical decision support, also known as PEPHAT, has an aim to support hospital workflows. It was originally created in 1989. And lastly, HL7 version 2 defines a series of electronic messages to support administrative, logistical, financial, as well as medical processes.
Interoperability in IHE standards. IHE are integrating the healthcare enterprises as an initiative by healthcare professionals and industry to improve the way computer systems in healthcare share information. It also promotes the coordinated use of established standards such as DCOM and HL7 to address specific clinical needs in support of optimal patient care. Just like in school, IHE also have vision and mission. Its vision is enable seamless and secure access to health information that is usable whenever or wherever is needed. And also its mission is to improve healthcare by providing specifications, tools, and services for interoperability. IHE engages clinicians, health authorities, industry, and users to develop, test, and implement standards-based solutions to vital health information needed. Medical imaging informatics system, evaluation, and quality assurance. First is PACS evaluation. The picture archiving and communication system is becoming more commonplace in today's hospital because hospital administrators have come to see the necessity of having such a system to serve physicians and patients even though it is expensive. PACS also have the primary objective is to make image available and accessible on multiple workstations simultaneously, which will aid in clinical decision making and providing efficient patient care. PACS employs Internet as a means of systemizing, archiving, retrieving, distributing, and transferring image to different healthcare centers. This technology, when exploited further can provide advanced technological solution such as holographic packs, enterprises packs, and virtual packs. So holographic packs, which couples a single department through new storage technologies, and enterprises packs, which supports vertical and horizontal integration between specialties and the departments. And the last is virtual packs, which across the enterprise will enhance packs performance. Also, in packs, there is advantages. Its advantages is increased communication between the radiologist and the referring physicians, decrease in instance of missing image, higher image access speed provide internal and external members access to image, and increase physicians' job satisfaction, and make all the departments more efficient. Second is workflow efficiency. First is, what is workflow? Workflow is a set of tasks grouped chronologically into process, and the set of people or resources needed for those tasks that are necessary to accomplish a given goal. An organization's workflow is to comprise of the set of processes it needs to accomplish the set of people or other resources available to perform those processes and the interactions among them. Workflows are designed while others arise organically and evolve. The system and methods by which organizations accomplish specific goals differ dramatically. Some organizational workflow seems more straightforward than the other. Most often, when workflow processes are looked at in isolation, the processes appear quite logical and even efficient in acting to the, accomplish the goal. It is the interaction among the processes that is complex arise complex arise. Some of these interactions hide conflicts in the priorities of different roles in an organization. Third is evaluation of data storage, disaster discovery, data flow, fault tolerance, networking latency, and interoperability. APACs contain different types of data and databases, which have traditionally been stored in different formats. They include image data, demographic data, and DCOM data, as well as functional data such as image enhanced. Vendors often use propri- proprietary form. Vendor, vendors often use proprietary formats to store data, even when complying with DCOM requirements. DCOM is intended to ensure interoperability, specifying standard formats for data entering and exiting the archive and workstations. Data migration is important issue in archive technologies because it is the fastest changing packs components and new technologies are being offered. Over the 5 years, PACS archive architecture has evolved from multi-year system with multiple types of storage media to single-tier architecture with all studies stored on spinning disk. The multi-year system in early PACS used combination digital storage arrays like jukebox, media, and shelf storage, and they require multiple types of data readers and retrieval methods. The newer single-tier architecture offers many advantages. Medical images typically must be retained for a 7-year period, although longer retention is required for pediatric and mammography image. Archive operation basic. So archive is the heart and brain of PACS. It is the intelligence command center that stores image pixel data, patient demographic data, DCOM data, and media management data. And it communicates with all the other system components. The archive is also the most expensive component of PACS, and its functionality will make a break of investment. Archive characteristics should be the most important criteria for system selection in purchase of PACS. All PACS workflow functionality and performance are dependent on the capability of the archive. So, a central image archive supporting multiple location and image types has these additional benefits. Archive also have benefits. So it has skill set and sets and resources to support the archive and network. Radiology only has to support the PACS application. The number of archives and databases in the hospital is reduced. Fewer FTs are required to support the system 24/7. It is easier to meet fault tolerance, redundancy, and high availability requirements. It is easier to achieve 99.99% uptime for both archive and network. It is easier to manage security. It is easier to become HEPA compliant and provides better disaster recovery and continuation of business capabilities. Medical image consists of the DCOM data containing patient demographic information and image data containing pixels information. Patient data are text-based, ranging in the low kilobyte size, and are usually managed with a commercial relational database management system. Medical image data are different because of their size. There is 5 MB to 1 GB per study and getting larger. And objective-oriented databases are used for storage and retrieval.
That's data migration. Before that, I will discuss what is PACS or Picture Archiving and Communication System. This system electronically stores image and reports instead of using the old method manually filing, retrieving, and transporting film jacket, which are used for storing X-ray film. PACS system combines software and hardware for the purpose of storing image on both a short and long-term basis. PACS system is much more efficient method for distributing, retrieving, and managing medical images. In PACS data migration, data is not like changing film or printer suppliers. It requires a thorough understanding of how the archive and media function. The image databases must support the ability to adapt over time. Any storage media will be unsupported and obsolete before image retention requirements has been satisfied. Having all images online all the time greatly enhances performance, streamlines workflow, and make data migration less costly and time-consuming and much easier to perform. In data migration, there are several instances in which a fax vendor or user needs to migrate patient data from one fax digital image archive to another. When a legacy fax system is replaced with a newer fax system, all patient data stored on the old system needs to be migrated to the new one. The operation must be done while both systems are in normal use. When all data has been moved, the old system is de-installed. Disaster discovery and recovery. Many hospital IT disaster recovery plans are focused around HIS recoverability, with facts as an afterthought. The most important role that radiology must play in disaster recovery is to partner with IT resources to develop the plan. Although it is true that IT must be able to find a backup tape, but to put the tape in a drive and recover lost data, IT does not necessarily know the tolerance for downtime of or the ultimate impact to the department. In discovery and recovery, disaster recovery focuses on an organization getting back on its file after disruption of failure. Business continuity planning is centered on keeping things running while a disaster occurs. It also involves planning not only for technical troubles but physical issues as well. Radiology should partner with IT to develop departmental contingency procedures and processes that complement the IT system recovery efforts. Disaster recovery facts. Disaster can do appear in a variety of forms. To a system administrator, fax disaster may be thought of as a result of technical failures that impact overall performance. To the radiologist or clinician, a disaster may be perceived as a single exam that cannot be immediately viewed. The focus of this section will be the prevention of fax disaster caused by the actual loss of data. The fax disaster recovery. The integration of fax has improved access to patient image retrieval and storage. The authors emphasize the importance of having a robust disaster recovery plan in place to minimize fax disruption. In data in fax disaster recovery, there are two basic strategy for storage exams in safe location. So first, what is safe? Safe is refers to a remote or second location that is unlikely to be affected by the same events that lead to the data lost at the primary site. So the two basic strategy is desk to desk and removal media. So desk to disk simply refers to the replication of exam data to other desk storage device daily located at remote data lost at the primary safe. While on the other hand, removal media is the primary paths site hosts a computer running software that manage the process of moving exam from desk to removal media and removal media back to desk. So it is a vice versa process. Next is the fault tolerance. Fault tolerance refers to the ability of a system to handle hardware or software failure while continuing to behave as if there has been no failure from the perspective of the end user. There are multiple degrees of fault tolerance, which can be as simple as planning for power interruption or as involved as being able to sustain a multi-server failure. A common fault tolerance implementation is referred to, a failover. So a failover is refers refers to the practice of mirroring a system so that every function that a server performs can be performed on a duplicate system. When the primary system fails, the backup system automatically takes control and satisfied all incoming requests. So the failover clustering is a backup file for the primary side. Robustness and fault tolerance. Robustness applies to several important elements in the system that allows administrators to provide high-quality service. This includes items such as self-monitoring capabilities, ability to interact with third-party software, and resilience to hardware failure. So robustness or fault tolerance, a robust system will also allow users to be able to work with the system without understanding the architecture or even knowing when a system fault has occurred. RIS assessment or radiology information system. RIS must be capable of satisfying a number of requirements, including satisfying the medical needs of the patient, producing the reports, image, and report processing, patient's appointment scheduling, the procedure for receiving and administering the orders, and other radiology procedures. So RIS or Radiology Information System is useful for tracking radiology images, records, and billing information. In Radiology Information System or RIS, when patients are scheduled, when they arrive, when their examination become ready for interpretation, when the report are finalized, and all of the intermediate steps. So the rapid report turnaround time or RTT, usually measuring the time from exam completion to finalized report or from preliminary report to finalized report. So RTT or report turnaround time is the billing cycle began until a report has been finalized. Slow RRT may affect cash flow. So what are RIS and PACS? RIS or Radiology Information System, it is a network software system for managing medical imagery and associated data. Our RIS is especially useful for tracking radiology image and orders and billing information. So in RIS, allows staff to make appointment for both patient, inpatient, and outpatient. RIS provides track patient radiology history from admission to discharge. RIS can generate statistical report for a single patient or group patient. RIS provide details financial records, keeping and process electronic payments and automatic claims. On the other hand, picture archiving communication system or a fax is a communication system, essentially a medical imaging technology used for storing, retrieving, and presenting and sharing images produced by medical hardware. So, on the other hand, fax is a medical technology used preliminary in healthcare. Fax store all the diagnostic image file. The main purpose is to easily manage the imagery that is needed to monitor the status of patient, giving through treatment and
Hi.
I am Janine Marie D. Inkig, and I will be reporting about the quality assurance for medical imaging. So, quality assurance for medical imaging is a basic diagnostic imaging quality assurance program that is a regulatory requirement in many provinces and federal institutions. An ineffective quality assurance program can lead to poor quality radiograms that can impair diagnosis, increase operating costs, and contribute to unnecessary radiation exposure to both patients and the staff. So, to achieve maximum benefit, all levels of management and technical staff must support and participate in the operation of a well defined program. So, let's proceed. Quality Assurance or QA. Quality assurance is a program used by management to maintain optimal diagnostic image quality with minimum hazard and distress to patients. The program includes periodic quality control tests, preventive maintenance procedures, administrative methods, and training. And it also includes continuous assessment of the efficacy of the imaging service and the means to initiate corrective action. The primary goal of Radiology Quality Assurance Program is to ensure the consistent provision of prompt and accurate diagnosis of patients. So this goal will be adequately met by a quality assurance program having the following three objectives. First is to maintain the quality of diagnostic images. Second, to minimize the radiation exposure to patient and staff. And lastly, and the third, to be cost effective. So before we proceed to quality control, in simpler terms, quality assurance is a program that monitors proper patient scheduling, reception, and preparation. So quality assurance deals with the process and it deals with the service that we render to our patients or to our clients. So quality assurance is not a single effort. It is the result of working together in an institution. So next, let's proceed to the quality control or the QC. Quality control consists of series and standardized tests that develop to detect changes in an X-ray equipment function from its original level of performance. The objective of such tests, when carried out routinely, allows prompt, corrective action to maintain X-ray image quality. It is important to note that the ultimate responsibility for quality control rests within the physician in charge of the X-ray facility, not with a regulatory agency. So quality control is designed to ensure the radiologist is provided with an optimal image produced through good equipment or machines, performance and resulting in minimal patient radiation. So quality control deals with the instruments used and the equipment used in medical imaging. So now let's proceed to the Radiology Department Quality Assurance Committee. So Radiology Department Quality Assurance Committee is, for example, in a hospital X-ray facility, the Radiology Department should establish a formal Quality Assurance Committee. So in the QA committee, it should provide the structure required to plan and evaluate the program and to resolve quality assurance issues and problems. So a quality assurance committee will also provide management with recommendations for direction to those charged with the various aspects of the program. The quality assurance committee should have an overall documented strategy with clearly defined work plans to achieve the goals and objectives of the radiology department. So the committee should also include representatives from all levels of the radiology staff, meet at regular intervals, and report directly to the department's management. It should recommend program policies to management and outline program specifics such as the duties and responsibilities of the staff. In addition, it should formulate the standards of image quality and regularly review the effectiveness of the program. So a formal quality assurance committee will promote the importance of and encourage participation in a department's quality assurance program. So, the Radiology Department Quality Assurance Program. It is a program that is developed under the guidance of the Quality Assurance Committee, specifically to address the needs of the Radiology Department. So, the Quality Assurance Program should include a written plan of action outlining policies and procedures. It should clearly define the goals and objectives of the department. So the quality assurance program should cover both quality control testing techniques and administrative procedures. The latter are to verify that quality control testing is effective such that the tests are performed regularly and correctly, the results evaluated promptly and accurately, and the necessary action taken. So the quality assurance manual should be developed in a format that allows easy reference by staff and permits future revision by management and the committee. So the content of the manual should be determined by management with the advice of the department's quality assurance committee, but it should contain the following items considered essential. So there are, I guess, 18 of these manuals of the quality assurance committee, the manual. So first, in the manual, a list of the radiology department, committee, personnel, and an outline of their duties, authority, and responsibilities. The manual should include a list of personnel involved in the quality control testing and an outline of their responsibility. Third, in the manual, it should have guidelines for equipment specification writing. The manual should have a list of the equipment parameters to be measured and the frequency of monitoring for each X-ray system and system component. So fifth, the manual should have a description of the performance standards with specific tolerance limits established for each quality control test. So six, a description of the method used to measure each parameter. Sample forms, worksheets, charts, and records used for quality control testing. So in the manual, the guidelines for equipment acceptance testing, a schedule of quality control testing for each equipment monitoring frequency. So 10th, the manual should have guidelines for photographic quality control, guidelines for recording equipment performance, procedures to be followed when equipment failure occurs or when test results fall outside the tolerance limits. So next, guidelines for the eject repeat analysis program. So the manual should have a list of the publications where detailed instructions for monitoring and maintenance procedures for each equipment can be found. So next, the manual should have guidelines for equipment appraisal and replacement. Next, the manual should have guidelines for the standardization of patient exposure, such as patient positioning, loading factors, and measurement of patient exposure. And the next, guidelines for quality acceptance of diagnostic radiograms. And lastly, the manual should have a schedule of management's review quality control reports and the quality assurance program. So let's proceed. So in the quality assurance program, they also have a personnel training. So in the personnel training, the quality assurance program includes the means to provide appropriate training for all personnel with quality assurance responsibilities and specifically to those directly involved in quality control testing. So a continuing education program is necessary to keep personnel up to date. So since quality control training is expensive, yet proven to be cost-effective, effort will be required by hospital management to ensure that adequate financial provision be available to meet this requirement. So, In quality control, they also have a technologist. So the amount of time spent on quality control should be adequate to perform the functions required for an effective quality control program. So quality control technologists should be allowed to devote at least 50% of their time to a quality control program in small institutions and full-time in larger institutions. So in the institutions with more than 500 beds may require additional help. So responsibilities for the quality control technologist should be to carry, so these are the responsibilities of the quality control technologist. So first, the technologist should carry out the day-to-day control quality test to the department's photographic, radiographic, and fluoroscopic imaging equipment and prescribe the quality control test schedule. Second, the technologist should record and or chart the quality control test measurement data. Third, the technologist should report any deterioration or trends in equipment performance to the radiology manager and staff using the equipment. Fourth, the technologist should initiate prompt corrective action and or preventive measures when necessary. And lastly, to oversee the repair of defective equipment performed by the hospital biomedical or electronic maintenance staff or by private service companies. There are still 6 of them. So 6, the technologists should oversee the repair of defective equipment performed by the hospital biomedical or electronic maintenance staff or by private service companies. 7, the technologist should perform the required tests to confirm that defective equipment was repaired and restored to the original level of performance. 8, maintain equipment performance records. The technologist should provide monthly reports on quality control activities to the radiology manager. And 10th, to develop new quality control monitoring and maintenance procedures as required. So let's proceed. So this is the diagram for the inpatient workflow. So I guess this is understandable. So next, this is the outpatient radiological diagnostic information system. So let's proceed to the PACS professionals development. So the need for specialized individuals to manage picture archiving and communication system has been recognized with the creation of a new professional title as the PACS administrator. So the PACS administrator requires skills sets that bridge the current domains of radiology technologists, information system analysts, and radiology administrators. So the introduction of picture archiving and communication systems into the radiology workplace was among the most important motivators in ushering in the digital revolution in medical imaging. So this revolution changed not only the manner in which images were acquired, transmitted, stored, and interpreted, but profoundly altered the task associated with professional roles. So technologists acquired new skills, radiologists learned novel ways of interacting with images and reporting findings, and radiology administrators faced unfamiliar challenges in integrating information's technology into the ongoing work of the department. So it soon became clear that the routine use of PACS in digital imaging called for a new and dedicated profession, which is the PACS administrator. At the same time, several organizations and private providers have begun to offer courses or training modules on PACS administrator. And this is pioneered by the Society for Computer Applications in Radiology, or SCAR. So the capabilities needed for a successful PACS administration go beyond those conventionally included in the position descriptions of RTs, radiology administrators, or IT specialists. So I guess that's it. Thank you so much for listening, and God bless us all.